Hey, what's happening, guys? We're back with the third and final part of our the beauty of Arduino is in it's that simplicity series. So in the first part, we use the potentiometer to control a fan. Right? Yeah. And then we use the MOSFET to, isolate the voltage from the Arduino. In the second part, we use the potentiometer as a sensor to control this 3 relay module for heat, cool, and fan. And in this final part, we're going to eliminate the potentiometer, which has been our stand-in sensor from the beginning, and we're going to use instead this guy here, which is the DHT11 sensor. It is a simple temperature and humidity sensor. It has 4 pins. One of them is not used. Now you're going to notice on this board, the only one that's marked really is the signal pin. So you need to do a little bit of multimeter work to figure out which pin goes to where. But in our case, it is ground, VCC, and signal. So anyway, the way it's hooked up here, I might as well go over it since I have this out of the way and you can see it. There is ground going to ground, VCC going to our 5 volts from the power supply, and our signal pin is going over here to Arduino digital pin 6, which you'll see when we get to the code here in a second. So what we're going to do now, instead of arbitrarily setting a value with the potentiometer, is we're going to read the value from the DHT sensor. We're actually going to read 2 different values. We're going to read a temperature value. In my case, it'll be in Fahrenheit because that's the way my brain functions. And it'll read a relative humidity value. And we're going to have to evaluate them separately. And then, depending on what those values are, we'll activate the appropriate relay or relays. Let's look at the code, then we'll come back and you can check it out in action. Okay, so let's look at the code. This is the Arduino temperature control relay module. And we have just 2 changes here. Include Adafruit sensor H and include DHT-H. Those are our libraries for the DHT11 sensor. Now we have 2 new defines, DHT pin 6 and DHT type DHT11. This one tells it what pin we're attached to, and this one tells it which type of DHT sensor we're using. Now here's where we're going to set up the DHT sensor. We'll be calling the DHT library. We'll be setting up the sensor called lowercase DHT using DHT pin and DHT type, which we have defined up here. I suppose you could just put 6 and DHT11 in there. But this is the way it was done in the examples, and like I said, I'm no programmer, so I'm just copying it verbatim. Next in our setup, this is our run once, of course. At the end of it, we simply tacked on a DHT begin statement, and that means we will start reading data from the sensor. And that's the end of our setup. That's our run once right there. No big deal. Now we have our loop. This is our continuous run. So the first thing we're going to do is we're going to create a float variable called H. How ingenious, right? And we'll read the humidity. And then we'll create another float variable called F. And we'll read the temperature. Now you notice it has that true there as a factor of that. That true makes it read in Fahrenheit for those of us who've landed a man on the moon. For those of you who have yet to achieve this monumental feat in science and engineering, you can remove the true and read it in degrees Celsius. And of course, I'm only teasing because in science we deal in degrees Celsius, so don't yell at me too much. Okay, here is our human feedback, or our GUI, our graphical user interface, which is not graphical. I guess it would be a TUI, a textual user interface. So we're going to print our heading of temperature, then we're going to print the actual temperature and the units. Skip a line, or not skip a line, but go down a line. Humidity, the reading, our units of percent. Then we're going to draw a line, skip a line. Now, nothing happens here until the end of the program. This just sends all of our data to the buffer. Then we're going to do our logic. Now, our logic is in two parts this time because we're actually evaluating two different things, the temperature and the humidity. So first we're going to evaluate the temperature, and we're going to say if the temperature is less than 63 degrees, energize the relay for the heating, de-energize the relay for the cooling, and print heat on. If it's higher than 70 degrees, we will de-energize the heating, energize the cooling. I think I got those in the wrong order, but you get the idea. And print cool on. I may change this one just because, you know, I'm a comics fan, and in honor of the Fantastic Four, I may change that to flame on. I'm not sure. Then we're going to say if the temperature is in the comfortable range, we want the heating and the cooling both off. That line does not need to be there. Oopsies. And if you download this from the repository, that line will not be there. This is live, folks. There are going to be errors. So that is the end of our first evaluation, where we are evaluating the temperature. We're saying if it's too cold, turn on the heat. If it's too hot, turn on the cold. And if it's just right, leave everything alone. Our next evaluation will be to evaluate the humidity. Yeah, you can choose whatever values you want here. I'm saying 55%. So if the humidity is greater than 55%, we turn on the fan. If the humidity is less than 55%, we turn off the fan. So now we've done our two logic sections here. And then we will display what's in the buffer. And we need to wait at least a second for the DHT sensor. You should give it at least a second between readings. So I buffered that up by 50%. You know, that's an engineer thing. You know, Mr. Scott on Star Trek was always, I kind of have it done in 4 hours, Captain. Of course, he'd have it done in 2 hours, and he would look fantastic. So if it only takes 1,000, call it 1,500, and when people find out they can do it better, they'll think, my God, that guy's a great engineer. And we clear the display, and we do it all over again. Get it? Got it? Good. Okay, I've got it powered up here. And if we come down here and take a look, you can see our values. We've got 77 degrees temperature and 49% humidity. So seeing that it is 77 degrees in here, that puts us into the cooling range, and that is our number 2 relay. I'm pointing at the view screen on the camera, and you can't see that. So at number 2, that's our number 2 relay. The cooling relay, as you can see there, is lit up. And our humidity is just a little bit low, but I have a way to fix that. That should kick up the humidity. There you go. You can see now our humidity is jumped up to 56% and went down to 54%. And the fan turned on and turned off. Let me try that again here. Hold on. Oh, knocked the power rail off. Paul, you dummkopf. There we go. 57% humidity, 62% humidity. The fan is on, the cooling is on. You can see we've got both going on here. Now we're down to 57% humidity, 56. Well, that drops one more point. The fan should kick off, and there it did. And you can see now it says only cooling is on. So we've gone from a basic concept of simply reading anything, in the original point we used a potentiometer, to control anything. And like I said, that is truly the beauty of Arduino. there are millions of sensors. I don't know if there's millions. Let's say there's thousands of sensors you can get. You can read temperature. You can read electrical current. You can read voltage. You can read electric fields. You can read light levels, UV levels. I'm not going to list them all. Anything that you want to your Arduino to process, you can find a sensor to read it. Then your Arduino processes it and does whatever you want by simply turning on or off digital pins. You can use some analog pins too, but basically it turns on and off digital pins to turn on and off whatever external devices you want. This is hugely powerful and incredibly simple. To do this with discrete components would be extremely difficult. You would need somebody trained in electronics to do it. With an Arduino, just about anybody can do it. It's not hard, I promise you. Start simple. Read the value from a potentiometer. Make your Arduino do something with that value. Before long, you've got yourself a moderately complicated system that you built yourself, and you should feel proud, because this is cool, and this is what makes electronics fun. So if you enjoyed this, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. That's it. I'm out. Peace.